Hi everybody, here's your video for Coulomb's law. Alright, let's jump right into a scenario. So let's say we have two charged objects. One is positively charged at 4.7 coulombs. The other is negatively charged at negative 2.1 coulombs. And they're a distance of 1.2 meters apart from each other. Our question is, what is the force that exists between these two objects? Okay, so let's start by mapping out the interaction. We have a positively charged object and a negatively charged object. We know they're going to attract each other. So the force on 1 by 2 is going to be to the right, and the force on 2 by 1 is going to be to the left. Now Newton's third law tells us that force on 1 by 2, force on 2 by 1, these have to be equal forces. The question is, again, what is that force? From our experiences in the sticky tape lab, we know that force, that electrostatic force, is going to depend on at least two things. The first being the amount of charge. Shouldn't say size, should say amount of charge that each object has. That is, if the object has a larger imbalance of positive or negative charges, it's going to have a higher charge. We should see a difference in the electrostatic force. Okay, and it also should matter on the distance between the objects. In the sticky tape lab and pretty much everything else we've seen that as the distance between the objects decreases, that electrostatic force increases. So what is the relationship between charge, distance, and the electrostatic force? That is given to us in something called Coulomb's law. Coulomb's law says the electrostatic force, I'm going to abbreviate it FEL there, is equal to K Q1 Q2 over D squared, where Q1 is the charge of object 1, Q2 equals the charge of object 2, D equals the distance between the objects from center to center. Now, hopefully you notice that this looks really similar to something else that we've already done in our class, and that was the force of gravity. Our last unit, we learned that force of gravity is equal to big G times M1 times M2 over distance squared. And these equations look really similar. So the force of gravity depends on the mass of the objects and the distance between them. The electrostatic force, the force we've been experiencing all unit, depends on the charge of the object and the distance between them. These equations are really, really similar. Now the one difference is that instead of a capital G for our constant, we have a lowercase k. This lowercase k is known as Coulomb's constant, and it's always, always, always going to be 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. So k is always going to be that value for any problem we ever do. Let's go ahead and solve this problem. So we already established that we have the force on 2 by 1, force on 1 by 2. This is the force that we're solving for. We have our equation. Let's start plugging things in. So up top, we start with lowercase k. That is always our Coulomb's constant, always 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. Then we have Q1. That is given to us as 4.7 coulombs. Q2 is negative 2.1 coulombs. and the distance between them is 1.2 meters squared. I would encourage you at this point to pause the video and try plugging this all into your calculator and see if you get the same thing that I do. Don't forget to use the E button on your calculator. I end up with 6.16 times 10 to the 10th, and we're calculating a force, and we know that forces are always in newtons. Now, if you're very astute, you may notice that there is a negative. Technically, if I carry that negative through, I should end up with a negative 6.16 times 10 to the 10th. But as we've always talked about in this unit, or any unit, negative sign just indicates direction. And we know what direction these forces are acting on. These forces are pointing inwards to make them attract. So I'm typically, the negative or the positive is not a real big deal. I hope this video helped. We will be doing more examples in class. Thanks for watching. If you have any questions, please let me know. Thanks for watching, everybody.